Assalamualaikum students, this is Sir Shakil, Physics, O-Levels, IGCSE and A-Levels teacher. Okay, today our topic is from IGCSE O-Level Physics, and that is turning effect of forces. We'll go through for a quick exam revision for these syllabus points. First of all, if you look on the syllabus content for turning effect of forces, we have to describe the moment of force as a measure of turning effect, and then we have to understand the factors about the force and the distance from the pivot. We have to look what is pivot. Then we will calculate moment by multiplying force and perpendicular distance from pivot. We will apply principle of moment to balancing of a beam about a pivot, and we will apply principle of moment in everyday situation as well. Okay, let's go into the basics of moment of force. Before going into the basics, first thing that we have to look upon is effect of forces on objects. So effects of forces on objects. Whenever a force acts on an object, it can make three type of changes. Number one, object can accelerate. Number two, object can decelerate. Like if object acts on object, force acts on object, it can speed up or it can slows down. So that is the effect of force. Okay, number three one is object can be deformed. Object can be deformed, like it can be extended or it can be compressed. And number four is that object can change direction of motion. Direction from linear motion to curved or circular. So these are the fourth one. But the fifth one is object can be rotated about a fixed point. And this fifth one is actually known as moment of force. In other words, we can say this is moment of force. The turning effect produced by force about a fixed point is known as moment of force. So if we go into the definition of moment of force, so we will say that the exam definition is product of force and its perpendicular distance from pivot. Okay, in this thing, first we have to look what is the pivot. What is the pivot? Pivot is also known as axis of rotation. And this is the fixed point about which object is going to be rotated. Fixed point about which object will rotate. Okay, and its significance is that all the distances are always measured from pivot. All distances of forces are always measured from pivot. That's why it is very significant that you have to measure the distance of force from this point, which is known as the pivot point. Okay, moving forward, we have to look upon the basic the equation of the moment of force, and the equation for moment of force is moment of force equal force into perpendicular distance. From pivot. So in other words, we can write it as moment equals force into distance, and its unit will be Newton meter. And then its types will be clockwise moment and anti-clockwise moment. So first one will be clockwise moment and second anti-clockwise moment. Okay, so if we now look upon a simple example, let's say we are having a beam, and let's say this is the beam, and let's say this is the pivot, which can be a nail inserted into the beam, I mean to the wall. And let's say the beam is a uniform mass and its center of gravity is at its center and its weight is, let's say, 20 Newton, right? And then let's say no other force is acting on it. So what would happen is that this rod or beam is going to be rotated due to weight, and it will be coming down like this way. So we'll say it is clockwise moment. So the weight of the beam is going to produce clockwise moment. So we will say that moment due to weight of the beam is equal to its force is 20 multiplied by its distance from the pivot. So this is the distance. So let's say this distance is 2 meters. So you're multiplying with 2. So your answer will be 40 Newton meter. And this would be clockwise. Right? So that's all. In simple situation, you can apply this moment. So this is clockwise. Let's look on the example of anti-clockwise. Let's say there is another beam, and let's say that is pivoted from here center with the edge placed below it. So this is the pivot point. This is the pivot from which it is supported. And let's say someone is applying the force in this direction, and let's say the force is 25 Newton now, and its distance is again 2 meters from the pivot. So now if you want to measure moment due to force F, that will be 25 into its perpendicular distance from pivot, which is 2. So that will be 50 Newton meter anti-clockwise. Anti-clockwise. Why? Because this force is going to be rotated the beam in upward direction, that is going against the clock rotation. So that's why we say this is anti-clockwise rotation. Okay, now moving forward to some other concept, which is principle of moment. Now for moment of force, it can be a single force, but there can be multiple forces acting on the object. If multiple forces are acting on the object, then we will use another law, that is another principle, that is known as principle of moments. So let's go through that. Principle of moments. Oh, before going into principle of moment, sorry about that, let me tell you about the factors, because we're missing that. Factors. So factors that can affect the moment of force. So factors always come from the formula. So the first factor for the moment of force is actually the force. If you keep the distance, perpendicular distance constant, it means increasing the force will increase the moment. That's quite straightforward. Like if you increase the force, of course, the moment will increase. The second one is moment of force proportional to its perpendicular distance from pivot. Perpendicular distance from pivot. So that again is a simple thing, that if you increase the perpendicular distance, the moment of force is going to be increased. So that's both the factors are directly proportional to the moment of force. Okay, let's look upon a situation in which more than one forces are acting on the object. So let's say if this is the object and this is, let's say, pivoted from one point, which is, let's say, this point. Well, something happening. Okay, so this is the pivot and its weight is acting from here. And let's say another force is acting from this point and another force acting from this point, which is, let's say, force Q, and this is still balanced. So we say when multiple forces are acting on object and trying to rotate the pivot, but if rotate the object about the pivot, but if it is balanced, or even if it is rotating, what we have to do, like for multiple forces acting on object, multiple forces acting on object. The first case in this will be balance case. Let's say the object will be balanced. Object is not moving, is not rotating. It means that we will say that the moment due to all forces will be equal to each other. So we will say that clockwise moments equals to anti-clockwise moments, because some forces will be producing clockwise movement, some will be producing anti-clockwise movement. So when both the moments will be equal, then there will be no net rotation. So this we will study in principle of moments. This is actually principle of moments. For B, we have to see that for B, we will say that rotational case. Let's say if forces are acting on the object and object is not balanced, so object is moving, object is rotating clockwise or anti-clockwise, rotating clockwise or anti-clockwise, then it means that either like clockwise moments will be greater than anti-clockwise moments, then obviously the net rotation will be in clockwise direction. And the other thing can be if anti-clockwise moments are greater than clockwise moments, then of course the object is going to be rotated along anti-clockwise direction. So this case, these both cases are from the case of resultant moment. So how you will find the resultant moment? Just find the clockwise moment and anti-clockwise moment and subtract them, like bigger minus smaller. It's always big minus small. So that will give you the resultant moment from either of these two. And how can you find the moment? It's simple. You have to use the equation force into perpendicular distance. Apply this equation to find clockwise moment or anti-clockwise moment, and then you have to subtract them to look for the resultant moment. Okay, now let's look upon our main topic, which is principle of moments now. Principle of moments. So principle of moments is applied when two or more than two forces are acting on object. So first thing is two or more forces acting on object. The next thing is that object is balanced. Object is balanced or the object is in equilibrium. Then you will be applying this principle of moment. So let me write its statement first. Statement is for equilibrium condition, sum of clockwise moments must be equal to sum of anti-clockwise moments acting about same pivot. This is the statement for principle of moments. Okay, let's move forward. There are some questions, but before that, we have to do something else. I need to tell you some more stuff related to principle of moment, and then we'll jump into solving the past paper questions. Okay, so what is the equation of principle of moment? The equation is sum of clockwise moments equal to sum of anti-clockwise moments. And well, the example can be, let's say again, this is a beam, and let's say this is, let's say this is the pivot, and let's say this is force F1 and this is F2, F3 is from here and F4 is from this edge, and all these forces are having distances. Let's say the distance of F1 is D1, the distance of F2 from pivot is D2, the distance of F3 is D3, and the distance of F4 from the pivot is D4. Okay, so now we know that F3 and F4 are producing clockwise moments, and F2 and F1, these are producing anti-clockwise moment. So if this rod is balanced, then we will say that clockwise moments equal to anti-clockwise moments, or anti-clockwise moments equal to clockwise moments, whatever. Okay. So now you will be applying the equation F1 into its distance D1. So F1 into D1, this is moment due to F1, plus F2 into D2, this is moment due to F2, because it says sum of the moments. So this is F1 moment, this is F2 moment. So you add their moments is equal to sum of clockwise moments. So this is F3 moment and this is F4 moment. Okay. But now let me tell you some very important points. To solve a question. Applying principle of moment. Okay. Okay, but the first point over here will be looking for the pivot. Pivot can be single pivot, and there can be two pivots as well. If two pivots are there, then select one of them as standard pivot. Standard pivot is one from which you will measure distance of each force. So if two pivots are there, you have to select one of them. Either it will be given in the question or you have to select one of them as the pivot. Okay, number two is forces. So some forces will be given in diagram. If it is given in diagram, that's really good. And some forces will be not given in diagram. Not given in diagram, but included in statement. And I will tell you about this as well. Let's say, let's talk about these forces. Point number two. One thing is weight of uniform mass plank or rod. So that will be acting from center of gravity point. So you have to look for the center of gravity point, and from there you will mark the weight. And the second point in it is normal reaction forces, normal reaction forces. So these are the contact forces that acts at point of contact and in vertically upward direction. And then the next thing is tension in cable, tension in rope. So tension in rope is always away from applied force, always away from applied force to the rope, or it's always towards the fixed end of the rope, always towards fixed end of rope. Okay, let me tell you a few examples of it before moving forward. Okay, so this is like the second point, which is forces. And let me tell you something about the forces. Let's say that if this is an object, uniform mass object, let's say they said that this is a uniform mass plank. Okay, if it is a uniform mass plank and its length is 2 meters, its length is 2 meters, then its center of gravity point will be at 1 meter from both the ends. And from its center of gravity point, its weight will be acting in downward direction. And if this is placed on two supports like this support is P and this is Q, then from P, the normal reaction force is acting upward, which is FP, and from Q, the normal reaction force is acting upward, which is FQ. That's the thing I was talking about. And then let's say if this is a plank, uniform mass plank, and it is held at rest by two ropes, which are tied up to a support like this. Okay. To draw them again. Okay, so let's say these are the two ropes. Okay, so in this rope, let's say its weight is acting from center of gravity in downward direction. So T1 is acting upward and T2 is acting upward because the weight is downward that is pulling the rope. So that's why T1 and T2 are in upward direction. That's the thing I told you over there. Okay, so number 3 is perpendicular distances. Perpendicular distances. So perpendicular distance of each force is always measured from selected pivot. So measure or mark distance of each force from pivot. So you have to measure. This is the most important point, and students usually do most of the mistakes in marking the distance. You always have to measure the distance of each force from the standard pivot. Okay, number 4 is type of moments produced by forces. You have to see that what type of moment is produced by force. It can be clockwise, it can be anti-clockwise, like clockwise or anti-clockwise. So let me take you back to this example. If you consider P as your standard pivot, it means you have to measure distance of each force from the pivot. And let's say another thing, let's say a box is placed over there as well. Let's say this is a box and its weight is, let's say it is B, its weight is B, and it is placed at a distance of, let's say 0.5 meter from one end. Okay, then your standard pivot is P, which you have selected that, okay, P is my pivot. So now you see how many forces are there. So if you look upon it, you will say that first force is FP, second force is weight of plank, third force is weight of box, and fourth force is FQ. So 4 forces are there. So this is your standard pivot P. And the weight of the block is acting from center of gravity. Now what you have to do is you have to look for the distance of each force from this pivot. So let's say FP is not having any distance because it is acting or right on the pivot. So for FP, you will write its distance as 0. For W, its distance is 1 meter. So you will write 1 meter with W because from pivot it is 1 meter. Okay, for FQ, it is 2 meter because if you look, FQ is 2 meter away from P, so its distance is 2 meter. What about B is that as total is 2 and this is 0.5 meter, so you will subtract it. So 2 minus 0.5, so you will get this distance 2 minus 0.5, which is 1.5 meter, because you have to measure the force distance from the pivot, so its distance will be 1.5 meters. So you will write all the distances with the forces. Now you have to see that which force is producing clockwise moment and which force is producing anti-clockwise moment. So for that, you can clearly see that this weight and this B both are producing clockwise moment. And this FU is, as it is upward, so it is producing anti-clockwise moment. And this FP is not producing any moment. Why? Because it is passing through the pivot, so it is not producing any of the moment. So that's how you can find the types of moment. So again, if I tell you by a simplifying situation, let's say like this, and let's say your pivot is over here, and this is the weight. So you will clearly see that weight is rotating the object in clockwise direction. So you will say, okay, this weight is having clockwise moment. And then if we talk about the other weight, which was B over here, the weight of the box, which was placed over here. So you can clearly see that this will always rotate. This can always rotate the object in clockwise. So B is always rotating it in clockwise direction. Okay, let's talk about this force which was acting upward. Let's say FQ. So as this is upward, so this will be rotating the object in anti-clockwise direction. So you will say for FQ, it is anti-clockwise, right? And for FP, as it is moving through the pivot, so it is not having any perpendicular distance, so there is no moment for that. So this is the way to find the type of moments. Next thing is apply equation of principle of moment. You have to apply that sum of clockwise moment is equal to sum of anti-clockwise moment. So sum of clockwise moments equals to sum of anti-clockwise moment. So summing it up, everyone, the most important points which you need to consider, like there are, while solving the past paper question, which we will solve right after this page. What are the most important points for applying the principle of moment? So the important is, number one, if object is uniform mass, its center of gravity will be at geometric center. Okay, number two is, while applying the equation, you have to look for pivot, then for forces, then for their distances from pivot, then for their type of moment, and then equation of moment. So PFD. So PFD and TOM. Tom is type of moment, and then EOM, equation of moment. So these are the points 1, 2, and 3. PFD, pivot, force, and distances. TOM means type of moment, and then EOM mean equation of motion. So equation of moment. So you have to apply these three to all the questions, for all moment questions, in which like 2 or more than 2 forces are acting on the object. Okay, so now let's move on to solve one of the question I have selected for you. It's from March 2017. Question paper 42. Okay, a stationary object is attached by a number of forces. State the condition which must be true if the object does not accelerate. If the object does not accelerate, it means that resultant force is zero. Resultant force is zero. And the object does not rotate, it means resultant moment is zero. Resultant moment is zero. Okay, let's move forward and apply the thing that we have learned over here just a while ago. Figure 3.1 shows a boat that has been lifted out of a river. The boat is suspended by two ropes. It is stationary. So two ropes are there. So in one rope tension T1 is upward and in second rope tension T2 is upward. Well, the weight of the boat acting at the center of mass is 24 kilonewton. So this is 24 kilonewton, which is acting from center of mass. The tension in the ropes are T1 and T2. Okay, and then the distances of the tension from the center is also given. So what you have to determine is the moment of weight of the boat about point P. So when they say about point P, it means this is the pivot because they are referring it as the pivot. So P is your pivot. So the moment is equal to force into distance. What is the weight? It is 24 kilonewton. Kilo is 10 to the power 3, and its distance of weight from the pivot is 0.4 meter. So you will simply multiply these two to get the answer. So it is 9.6 into 10 power 3 Newton meter. So that's a simple thing. The tension T1. Now you have to find the tension T1. Okay, so this T1 is to be determined. So as they said that the boat is stationary. It is written over there, the boat is stationary. It means you have to apply principle of moments over here. So because it is 3-mark question, so definitely you're going to apply principle of moment over here. Principle of moment. Okay, when you apply principle of moment over here, so first thing is P, F, D, and Tom and Eon. So pivot, okay, pivot is P, it is clear. Forces, so T1 is the force, T2 is the force, and then 24 kilonewton is the force. Okay, that's already given. And then the distances, all the distances are already given. And type of moment, we'll see that T1 is producing a clockwise moment, and this 24 kilonewton is producing moment in anti-clockwise. So this is anti-clockwise, and T2 is not producing any moment because it is passing through pivot. Okay, so we will say that over here, clockwise moment is equal to anti-clockwise moment. So for clockwise moment, we'll be looking at T1 into its distance from the pivot, which is 1.20 meter. And for anti-clockwise moment, we have already done in part 1, that is 9.6 into 10 power 3, because this anti-clockwise moment we have already calculated. So making T as the subject, 9.6 into 10 power 3 divided by 1.20. So the answer is coming out to be 8. So 8.0 into 10 power 3 Newton is the tension T1. For tension T2, we will be using another thing, which is resultant force should be 0. Resultant force should be 0 as boat is at rest. So it means upward forces should be equal to downward forces. So upward forces are 2, T1 and T2, and downward forces is 1, which is weight, which is 24 kilonewton. But you just have calculated T1, which is 8 kilonewton. So T1 is 8 kilonewton, and then you can find of course, G2 by subtracting these two, 24 minus 8. So that will be 16 kilonewton. So you will say that 16 kilonewton is the weight. So it's sometimes you use, like as in 2, you use moment equation, and in 3, you use resultant force equal to 0. Okay, for next question, you can just stop the video and you can solve this question. Second question is March 2018, question 42. You can stop the video and you can solve this question. And after solving this question, you can comment in the chat box if you want to take any help. And this is another question. This is MCQ from October 2018, question paper 23, question 7. Again, you can stop the video and you can solve it, and then you can always take my help from by writing in the chat box. So thank you, students. I hope that this session could have been informative for you. In case of any question, feel free to contact me on WhatsApp or comment here in the video in the chat box. Thank you, students. Take care. Allah Hafiz.